All right, let's talk about edge AI or AI on the edge. Let's start with a scenario to introduce edge AI. Imagine that you have a manufacturing plant that needs to predict and detect equipment failures in real time. That might sound like a job for an AI model, right? But the problem is that the plant has no connectivity to the cloud. Data cannot leave the facility. So sending data up to GCP for inference is not an option. How do you solve this? Well, what we can do here is we can deploy the model directly within the manufacturing plant, running inference on local hardware. This is called edge AI. This is the approach of deploying a model locally. The model goes to the data rather than the other way around. The edge refers to the device or the location where the data originates, as opposed to a centralized cloud data center. So edge AI is useful when you need low latency, when you have connectivity constraints, or you have data privacy requirements that prevent sending data offsite. Let's talk about light runtime, which was formerly called TensorFlow Lite. This is something that could show up on the exam, and it relates to deploying models to edge devices. So you start by training a model in the cloud. You train your model normally in GCP using the full compute available there, and then you optimize and convert the model. This is where the model is compressed and transformed into a format suited for constrained hardware. And essentially, it's packaged into a TF Lite model. That is the extension of the file. The converted model would be bundled into that lightweight file format, and then you deploy for on-device inference. And you run the model directly on the edge device with no cloud dependency at inference time. So that's where you get the real convenience of that local deployment. Let's go over the key capabilities here. Model compression via quantization and pruning reduces both model size and latency. It lowers the numerical precision of the model's weights, shrinking the file significantly. And then pruning removes connections that contribute little to accuracy, so they're kind of unnecessary. The result is a much smaller model that still performs well, even if it's not quite as well. Light runtime is deployable on almost any device, and it has cross-platform runtime that supports Android, iOS, Linux, microcontrollers. So really it works on basically anything. It also supports hardware acceleration through GPUs, GPU delegates, Edge TPU, and Hexagon DSP. So it can take advantage of specialized chips when they are available, although they're not always available because we're talking about lots of different devices here. And its low memory footprint means that it can run on devices with just kilobytes of RAM, not necessarily needing gigabytes, although we're getting more and more RAM in these devices these days. Anyway, you need to know about Edge AI for the exam. There could be a question or two on it.